This is a presentation of the final project for the Human Factors in AI course offered by Duke University, which I'm doing as part of the AI Product Management Specialization. The ask of the project is to come up with a problem within my industry that might have a potential machine learning solution, describe the product that uses the solution, talk through how I would design the user experience with regards to AI specific considerations, and show how I would evaluate privacy and ethical implications for this product. The project will be evaluated on the basis of the following criteria: whether I've clearly understood the problem step by step through a task analysis, whether AI considerations in the user experience design are adequately explained, privacy concerns are identified and addressed, and ethical concerns are identified and addressed. The problem I've identified is within the healthcare space. I have 12 plus years of experience working in the healthcare sector closely with clinicians and patients, and have spent the past 5 years designing digital health products. That said, I'm not a clinician. Therefore, some assumptions I make here might need to be validated. Let's begin. General practitioners or GPs, as well as pharmacists, spend a lot of time reviewing asthma or COPD patients who are on inhalers and taking medications but are not getting better. For a lot of these cases, part of why they aren't getting better has to do with how they're using their inhalers. Over 90% of asthma and COPD patients don't use their inhalers correctly, and this is data from the UK. If the patient knew they were not using their inhalers correctly, then they could correct themselves and would get better. Therefore, they would not need to see a doctor or a pharmacist. In cases when the patient is using their inhalers correctly and still not getting better, they would then need to see a doctor or a pharmacist urgently and get their medications reviewed. The problem then is that doctors and pharmacists are spending their valuable time evaluating a lot of patients who might not need medication review and might be missing those patients who actually need the medication review. So having a readily available, reliable system that tells the patient whether they are using their inhalers correctly or not every time they use it would solve this problem. I have done a little task analysis here to explain the problem better. Our objective here is to, so if you see at the bottom right corner of the screen, our objective here is that the doctor or pharmacist needs to know which of their patients needs a medication review and which of them don't. Currently, on the left side of the screen, asthma or COPD patients who have an exacerbation event or an attack might be admitted to a hospital and treated, or might call their GPs. The GP then needs to know first whether that patient is already on inhalers or not. If the patient is on inhalers, the GP needs to check how they're using their inhalers. For the patient, the patient has to actually make a video call or visit the GP surgery in person. If the patient is using the inhalers correctly, the GP knows it is not the inhaler technique that's the issue and might recommend a medication review. If the patient is using their inhalers but not using it correctly, then the GP can demonstrate the correct use and then ask them to follow it. This is a long and cumbersome process for the GP or the pharmacist. There's long waiting times for the GP or pharmacist for the patient to see them. They don't like actually doing it because most of the time the inhaler technique is incorrect and the patient actually does not need medication changes, etc., etc. So there's lots of issues with this. It would be nice if something could screen those patients out who don't need a medication review, and the GP or pharmacist could only see those patients who actually need a medication review. This is where our AI solution can help. Imagine a mobile app that asks patients their asthma or COPD history and inhaler use history. Each time the patient needs to use their inhaler, they would then take a short TikTok-style 30-second video of them using the inhaler. This would be analyzed by our AI system, and it would tell the patient whether the inhaler technique is correct or not. If their technique is not correct, then the app would show them a video of a clinician demonstrating the correct usage of the inhalers so that the patient can learn and use it correctly the next time. If their technique is correct, but over time the patient isn't actually feeling better, then that patient needs further medication review, and this list can be sent to the GP or pharmacy, and the GP and pharmacy can make an appointment for that patient to come have their medications reviewed. So our AI system has effectively acted as a screening mechanism to screen out those patients who don't need a medical review. This system would first use a human-in-the-loop approach, using GPs or pharmacists to train the model by identifying correct or incorrect inhaler usage in videos sent by patients. Once the model reaches 99.9% accuracy, the AI model can be fully deployed without the human in the loop. To ensure our users are able to trust this system, we will incorporate transparency in our user experience design of the product. Within the app, we can explain how machine vision algorithms for action detection works. We can also talk about clinical studies that use AI ML for asthma and COPD prediction. We'll explain the human-in-the-loop system and let patients know that the model was trained by professional clinicians. We'll also track individual patients' exacerbation over time and use correlations of this with correct inhaler use technique. This will tell us whether our model predictions are consistently accurate or whether they're degrading over time. We'll communicate uncertainty at two different levels within the app. For patients, we'll show a 0-1 prediction. That is, we'll tell them if their technique is correct or incorrect. For clinicians who are training our model, however, we'll provide a probability value associated with this prediction. Using this, the clinician may decide to bucket the technique as correct or incorrect when the data is quite uncertain or in the middle, using their expertise and clinical knowledge. Because we're dealing with health data, we'll take privacy and confidentiality very seriously. We'll encrypt all data during upload, storage, and download to and from the cloud. We'll ensure the designated clinician is the only person who can actually have access to the patient's data. And once the model is trained, we'll ensure that only the patient has access to this data and nobody else. If we require retraining of the model, we'll extract features from the data and use that, and not any personally identifiable information of the patient themselves. We'll be working within the UK, so UK GDPR rules apply. This means that our patients will have the right to be informed, the right of access, the right to rectification, and the right to erasure. In terms of potential bias, there are a few potential sources of bias here. The main one being representational bias, that is, bias caused by the fact that we may not have a fully representative sample of the population for this project. This is because the people who use smartphones are predominantly younger, and the people who have chronic conditions such as asthma and COPD are predominantly older. There is an overlap, but that overlap might be quite small and might not represent everyone who we want to help. So that's a potential source of bias. Similarly, asthma and COPD patients are more women than men, and more African descent than white. So these might be overrepresented in our data. This might pose a risk that our predictions might not be as accurate for males and those of other ethnicities. And finally, we're creating an app that requires video capture using a smartphone. Those who don't have a smartphone, or those who cannot do video capture due to some disability, might be excluded from this altogether. We might also encounter measurement bias, although there's a slim chance of this. We're assuming here that if a person is using the inhalers correctly, that means the medication is entering into their system. And that's a big assumption to make. Sometimes the medications might not be entering the system even if they are using the inhalers correctly. And there might be all kinds of biological reasons for this. But this assumption might not always be true. In terms of ethical considerations for our AI system, we might encounter issues of fairness, accountability, and transparency. Our machine vision system might use a base algorithm that's trained on facial recognition data, which means it might have a difficult time identifying black females because historically facial recognition algorithms are trained mostly on white men's faces. If there are any issues within our app, the patient should be able to easily contact us for support. And that shows that we are accountable for the actions that the patient might take based on our app. We'll be using UK's NICE guidelines for clinical management, and this may not necessarily apply to other countries. Finally, with regards to transparency, as already mentioned, we will ensure users know how the AI system was trained, what data we used, etc. Because we'll be using complex neural networks for action prediction, we can create a simple set of business rules that explain to the patient how these models work. And then this will ensure that our AI is fair, accountable, and transparent, effectively delivering an ethical AI system. Thank you. That's the end of my presentation for the course.